Okay, small tip for guys who are using harness from CYC sets, as I'm doing. The only problem with this set from CYC is that it's using different type of pins arrangement comparing to the standard layout of ASI pinout. So what I had to do is to move the pin brown responsible for signal from throttle from port 12 to port number 7, like this. If you don't do this, you will not have throttle working properly. For those of you who are interested how whole sensor cables are connected between the motor and ASI harness, here you can see the pinout. So on the left side you can see the cable from the motor, on the right going to the ASI. So brown and red are plus 5 volt voltage cable. White and black is ground, and then you have A, B, C whole lines. So line A is yellow and white, line B is green and blue, and line C is gray and green. Okay folks, everything is connected as it should be, so I'll just show you how to configure the motor using Kilowatt application. So we'll just start the system. So that's what you get. So then you go to the application. I already preset everything, so I will just repeat what I was doing. So you go, I'm using ASI BAC 2000. I'm just going to setup mode. Then you click on motor. You have selection of different motors. So I'll just go to generic Hall sensors. Then when motor is ready, just click on continue. And then application is doing some measurements. And calibration is done. And then after that you need to configure the throttle. I did this already, but I can show you quickly once again. So you need to have a throttle nearby. And then you need to press it once or twice. And then when you are pressing you should see 100%, and it's released 0. And everything is fine. You just press, it looks good. Calibration is done. Okay. And I can just show you how it works quickly. So I'll just go on level 1. Start recording maybe. That's how motor works. You see, I get this error 24H. It indicates that something might be wrong with Hall sensors in the motor, but hard to say, to be honest, because it's quite fluent reaction. I don't hear any jittering. But you never know. Let's see on the power indications. You see the low values, but there is no resistance on the motor, so I'll have to put it like on the bike. Apply some friction on the wheel so that I would see the proper power. Okay, and here you can see the dyno indications. So the only thing for me is just to configure it a little bit better, probably. But it's hard to say, you know, if it's good or not now. I just need to put it on the bike and then see how it goes. So let's do it. Okay guys, to test the motor hall sensors, the best idea is to use this device, controller motor tester. So I made a connection between the hall sensor cable to this motor hall sensors connector from the test device. And what you need to do is just to rotate the motor axle. And when you are doing this, you will see the blinking lights between blue, green and yellow lines. So when you are rotating slowly, these lights should blink in this sequence, one by one. I think it's alright. It's not jumping from A and C by accident, it's going between A, B and C. Alright, test completed. As you remember, I had some problems with hall sensors error on this motor. It was connected to ASI 2000 controller. But I managed to do this. I can just show you clicking in the software. It's not very user friendly. So I think I will have to make like a separate video to showing the functions of this. But it's possible, you know. You don't have to buy, by the way, original cable connecting controller to the computer. You can create your own one using, for instance, this Bafang tuning module. So here you can see how it's connected. The cable is connected instead of the display. I took out the controller just to swap the cables. What is important, I had to switch the phase wires. You can see the configuration. And here is the program. It's too many parameters not to be explained in an instance. But I can just show you quickly how the motor works. Here, this humming noise is a sign that whole sensors are operating correctly. So there is no jitter. When we start to rotate, very smooth engagement. But noise remains as it was before. Alright, so that's it. I'll try to make a separate video for this application because there is nothing on internet, nothing on YouTube showing in detail what to do. So I'll be one of the first guys doing detailed video about it. ASI is very reluctant to do that, so it's something for me to prepare for you.